All right, so the first two questions here, which of the following is considered human capital? So human capital is not physical capital, it's what we learn in the process. Number of people in the workforce leads to a certain level of production possibilities. However, human capital is that knowledge that we acquire through education. So that would be part of human capital. Average percentage of income people give to charity does not lead to human capital, and the number of computers available at schools and universities is physical capital, not human capital. What is a correct way to measure productivity? Well, if we divide the number of workers by output, does it make sense? We want to look at total output and divide it by something. And then if we divide output by number of hours worked versus number of workers, number of hours worked makes more sense, because we'll see in the question 4 in this version of the quiz that otherwise it's very hard to compare the productivity of two different people if they're not working the same amount of same amount of hours. Which of the statements best explains the importance of real GDP per person? There's a few things that are important here, but I'll just highlight which one's right and why some other ones that you might see as right may not be right in this case. It is a useful measure of the health of citizens. Well, we know that real GDP per person would be like the average income level per person, or the average amount of money available in terms of production per person. But health, we don't know. Like, people could still be very unhealthy. It is a useful measure of the cost of living. No, the CPI index is a useful measure of the cost of living, but this isn't. It is a useful measure of well-being. Yes, if you have a country that has $50,000 worth of real GDP and another country that has $25,000, you expect the country with more, if we're talking about the same denomination, to be able to afford more, to be able to do more with their money. So this is the right answer. And it is a useful measure for economic growth. Well, it's good to look at economic growth from a real GDP perspective, but real GDP on its own is not enough. To measure economic growth, you need to look at the trend of real GDP per person over time. So if I only give you real GDP per person on a given year, you have no idea what's going on with economic growth. So that's why this one, that may seem good, is not a good answer. Don looks over reports on 5 of her workers. The question is, who has the greatest productivity? So Carol made 25 baskets in 5 hours, so on average 5 baskets per hour. Peter made 30 baskets in 6 hours, so also on average 5 baskets per hour. Rob made 40 baskets in 10 hours, so on average 4 baskets per hour. Jack made 55 baskets in 10 hours, 5.5 baskets per hour is now the highest. Jacqueline made 21 baskets in 3 hours, 7 baskets per hour is the highest one. So Jacqueline is the right answer. Last year, real GDP in Oceania was 620 billion, and the population was 2.3 million. The year before, real GDP was 502 billion, and the population was 2 million. What was the approximate growth rate of real GDP per person? This is just a simple calculation here. We could see that GDP has gone up by a little bit more than a quarter of this. So like 25%, but at the same time, population grew by 15%. So it has to be somewhere less than 10%-ish is going to be my answer. But I'm going to try to calculate this a little bit more accurately. So if I look at here, what was GDP per person in the initial year? Well, if I say 502 billion, I could, if I wanted to put it in a million, I can as well. It doesn't really matter because I'm just comparing the two, but to make it precise, let's say this is 502,000 million is 502 billion over this 2 million for this first year. So that gives me on average 251. And if I have the other case that we have 620 billion, so 620,000 million, and 2.3. Well, over the course of this time, I have this situation where I have 269, 565. So here I would want to put 269, 565 over 251,000 minus 1 times 100 to see how much this has changed over time. And if I do this divided by 251 minus 1 times 100, I get 7.4%. So it just requires a bit of calculation. And that was it for Chapter 7.